So I want to take you through some of these questions here. Let's look at the first question here. A drawing of a spacer block is shown below. And which of the following represents the front view? You have to understand this is the front. That's what they say there, front view. And the front is everything in white. So it's this and this. If I draw this shape, it's going to look like that. And then if I add this shape on top, it's going to come over and go down. So it's going to come over and go down. So it would be D for that shape, like that. In many microwave ovens, a turntable, so turn is to go around, slowly rotates food while the oven is in operation. The turntable, however, was not part of the original microwave design. Which of the following statements is most likely the reason the turntable is added to the microwave oven? The food in the microwave goes around and around and around to cook the food evenly. And here it says most likely. This is the reason, the number one reason for the food to turn. Number 3, a building contractor is reviewing plans, architectural plans for a new deck. The scale plan is every 1/2 inch equals 1 foot. The width of the deck on the scale drawing is 5.5 inches. So 5.5 inches. These are inches. This is inches. Which length or what length of decking material should be used to span the width of the deck with a single board while minimizing waste? So if every 1/2 inch is 1 foot and you have 5.5, that's the same as 5.5, okay? Then what you would do here is 5.5 divided by, and this number here, half is 0.5, this is 0.5, so 5.5 divided by 0.5, that gets you 11. And these are all, that's foot. These are inches, and that's inches. That's foot. Now, if you have 11, which material or how much material would you need to buy so that you minimize waste? So you don't waste a lot of material, you would buy C, 12. And then you can cut 1 off to get 11. Many types of models are used throughout the design process to help engineers create, develop, test, evaluate, and explain solutions. If the automobile company is ready to test a new full-size operational model, these models, this type of model, a model that is operational, is a prototype. These are models that are operational. The front view of the space of this piece of equipment is shown in the diagram below. Which of the following conclusions, they love this question, which conclusion can you get from looking at this diagram? Well, we can see it has 2 holes. Do we know the type of material by looking at it? No, it does not say the type of material, so no. The length and the width are not the same. No. And this says nothing about compression, tension, or anything like that. We know it has 2 holes, and that's it. An engineer just finished building a prototype of a lawn tractor, and it is powered by hydrogen fuel cell. Which of the following should be the next step? They just finished building a prototype. After you finish building, what do you do next? You construct, you build, you test. You test your prototype. Okay? This is a difficult question. If you have trouble reading diagrams, yes, but I really don't think it's impossible. The diagram below shows 2 views of a plant container. A plant container is where you would be growing small plants. This is the top view. This is the front view. What is the thickness? If you don't know this word, you have to look it up, of the plant wall container. And if you still don't know it, just so that you know it for the test, you need to understand what this word means. Thickness is how thick the wall is. Here, this is the thickness. It does not say on this drawing, but you look up here, and that's the thickness there. It's 7/8. During which of the following steps in the engineering design process would an engineer use the internet? You use the internet to learn, right, to do research, and that is research the problem. Let's see here. So we have the drawing represents the finished basement floor. What does W represent in the drawing? W is here. What does W represent in the drawing? Imagine this is a house. This is the basement. It is below the ground, so you need to go up and down into the basement. These are stairs. This is where you would go up the stairs to go up to the first floor. If you want to go down to the basement, this is a staircase. Okay, this is a little bit more challenging, but again, not impossible. And it says a scale drawing of a fitness center is here, shown here. The scale factor is 1/4 inch equals 20 feet. What is the total combined area of the pool and the locker room? What's the combined area? It says a 1/4 inch is 20 feet. A 1/4 inch is 2 of these lines. So that's 1/4 inch. That's 1/4 inch. This is 2. This is the second quarter. 3, and that's 4. And those 4 together make 1 inch. So each one of these is 1/4 of an inch. So they want to know the total area, and you need to know that area is length times width. So we need the width and we need the length of the room. If each 1/4 inch, 2 of these is a 1/4 inch, and they say each 1/4 inch is 20 feet, then this is 20, this is 20, 20, 20. Oh, we have 2 more. 20, 20, 2, 4, 6, 8, 10, 12. Right? That is 1,200, and that's feet. Okay. Excuse me, 120. Sorry. 20 times 6. That's 120. 120 feet. Okay. And here we do the same thing. We have 1, 2, 3. That's 20, 20, 20. That's 60 feet. So the area here is 120 times 60. We did spend time calculating area this year, and we did calculate areas of rooms. We did this for the classroom. This is 7,200 square feet. Hi. I don't think she's in her room yet. She usually has it open to say hi in the morning. So that's the area for this room here. Now let's do the locker room.
What are you doing?
I'm recording a video for my students so they can understand some questions. So we have... That's okay. Do you need to drop something off?
No.
Oh, okay. So each 1/4 inch is 20 feet. So we have another 1/4 inch. Remember, 1/4 inch is 2 of these lines here. 2 of these lines. 1, 2, 3. We have another 1/4. 4, 5, 6. This is 20. 20, 20, 20, 20. So that here is 120 feet. That's the length. And the width here is this 1/4. That's 2/4, 20, 20. The width is 40 feet. And that is, let's see, let's multiply. 120 should be 4,800 times 40, and that is the area for the locker room. Let's see where to write this. The area is 4,800 square feet. And now you have to add those two together. Let's add 4,800 using a calculator and 7,200, and you get 12,000. When you add this area and you add this area together, you get 12,000. Not impossible. Okay. A student has a drawing of the Federal Reserve Bank of Boston. Ooh, Boston. The building's height in the drawing is 25 centimeters. So he has, or she has, 25 centimeters in the drawing. Now the scale factor of the drawing is every 1 centimeter is 7.5 meters. What is the actual height of the building? So if the scale factor is every 1 centimeter, 7.5 meters, you have 25 centimeters. So you have 25 centimeters. 1 times 25 is 25. How many meters do you have? Well, let's do 7.5 times 25. You should have 187.5 meters. B. Okay. Which devices are required by the National Highway Transportation Safety Administration to be installed in every new automobile sold in the United States to supplement the protection offered by seatbelts? They're talking about automobiles, cars. These are cars. They're talking about seatbelts. What in a car helps protect you? So you have the seatbelt. This is what you sit in that keeps you safe in a car. So if you're in a car riding, you have the seatbelt. There's something else that helps is if you get into the crash, the seatbelt holds you into the seat, but then there's an airbag that also keeps you from moving forward. That's a general question. They ask general questions which are all over the place, but you kind of have to be prepared to do the best that you can on these questions. Okay, the drawing below shows a three-dimensional view of a simple wooden chair. Which drawing represents the front view? This is the front in this direction. That's the front. And if we just, even not looking at the answers, if you draw the front, well, I know I have 2 legs. I have 2 legs. Okay. Then I'm going to have this part here. That's this. I'm going to have these that go up, and then I'm going to have that. Right? And back here there's a hidden piece that you cannot see from the front. Well, let's go look at that. That is this here. That's C. What I just drew is C. A company is designing a new automobile braking system. After testing, the engineers report. So you test, they test, then the engineers present. This is sharing and explaining that they discover problems in the system. So after you test and then you communicate, which of the following should the engineers do next? The last step is redesign. In the 1800s, inventors built a device that could be used to send and receive encoded messages through electrical wires. Communicating through electrical wires, television is wireless, radio is wireless. So tape recorder does not use wires, telegraph. This is again a general question. They do like to talk about the history of communication. So this might be a communication question, but it's talking about the telegraph using electrical wires. Maybe that question's poorly placed, but still a question you might see. Okay. Which of the following is an example of an isometric drawing? You know isometric always has a corner on the front, so that's D. You need to know isometric, you need to know orthographic. These are orthographic drawings, 2-dimension. This is oblique because it has a flat front. And then this is isometric because it starts at a corner. A lot of information here, so this one's a bit of a challenge. This is a paper punch card. It's one of the first ways to program a computer. All right, very, very, very old technology from about 1950 to 1960. Punch cards were physically inserted into a computer to deliver commands. After punch cards, the technology was improved so that commands could be delivered using keyboards, mouse, stylus, and touch screens. Why did we create keyboards, mice, stylus, and touchscreen? It's so that we can use computers fast and simple ways. All right, back to drawings. The diagram below represents a new mechanical part. Which diagram shows what the right side view, which diagram shows the right side view of this part would look like in an engineering drawing? Right side view, this and this together. There's that. Then there's this. C. The diagram below shows a ship's wheel and its part list. Which of the following parts has a 2 millimeter diameter? Right, these are quantities. How many? Here you have some information on diameter. 2 millimeter. The only place I see 2 is this nail here. Nail. 2 millimeter. Do not say circle. That is not millimeter. Millimeters down here. 2 millimeter. Let's see here. Okay, what is the scale on this drawing? This is the dimensions of the interior walls of a room. This is 12 feet. That's 10 feet. They want to know the scale factor. Let's do this in inches because the answer here is in inches and that's feet. Let's look at this. This is 3 inches from here to here is 3 inches. Good morning.
Hi.
I don't know. It's very hot in this room. I'm recording something for my students, MCAS.
Want me to close the door?
Yeah, I'll be done in like 15 minutes probably. So that's 3 inches. All right. How do we get from 3 to 12? There's a magic number I can think of, and that is 4. Right? If we want to go 3 to 12, 3 times 4 equals 12, right? Or if we want to go the other way, 12 divided by 4 equals 3, right? So you have 4 or 1/4, because divided by 4 is 1/4. So that's B. 4 is the magic number. A company is thinking of developing thinking. They're generating ideas about the problem. All right. Based on the engineering design process, what should they do next? They've thought about, let's define a problem. And the problem we want to address is making a hydrogen-powered motorcycle. So after you define the problem, you're going to do market research. You're going to do research. All right. A drawing is scaled so that 1 inch is 16 feet. A wall section in the scale drawing measures 3 3/4. This, you should be able to convert that. This is 3.75. Another way to get this 7.5, if you don't know how to get this number here, 3 divided by 4 is 0.75. 3 divided by 4 is 0.75. Right? And this is a problem we did earlier. We already did this one time. We'll do it again. 1 inch is 16 feet. 1 inch is 16 feet. I got that here. We're going to multiply that because we have 3.75 inches. That's 3.75. 1 times 3.75 is 3.75. 16. Now we multiply both sides by 3.75. 16 times 3.75 equals 60. 60 feet. So 3.75 inches, 60 feet. Okay. A green roof is a vegetation system installed on a rooftop of a building. This is a green roof. It's got plants on it. This is a roof, techo, of a building. Some companies install these so that they can sort of provide an environment or a structure that's better for the environment. This collects a lot of water. It also gives you oxygen through photosynthesis for the grass, with the grass on the ceiling. Which of the following statements is supported by the diagram? What can you determine just by looking at this picture and only by looking at this picture? All right. We know that there's more soil than gravel. Look at that. There's a lot more soil than gravel. So look at this. The roof has more soil than gravel. We can see that. The roof adds no more than 6 inches of height. That's not true. It adds maybe more, because here's 6 and a little bit more. Adds no more than 6 cubic inches of mass. Mass does not say the weight of anything or the mass of anything there. The green roof has a drainage mat and a waterproof covering made out of the same material. You don't know the material of those objects. It is A. Several college students want to design and build a solar-powered car. They have choose the best solution. After you choose the best solution, what do you do next? Right? You choose the best solution, then you build the car. All right? They love these questions, and this is also just good to understand how to solve problems. If you are an engineer, if you're going to live your life, you need to solve problems. Sarah presented an idea for recycling used tires to an automotive company. If she followed the engineering design process, what is the first step in developing her idea? You always want the first step to be define the problem. Identify. Same word as define. The problem. Problem. Identify the problem. D. Okay, 26. The development of computer simulations, and we did this when we built bridges. We simulated the bridges on our cell phones using a game to model and test bridge designs to improve safety. Which of the following best explains why simulations improve safety? Well, it's so design flaws can be identified and fixed before you make it. We played the game on our cell phones to build bridges before we constructed or built the bridges. And that's so we could identify problems, flaws or problems with the design. Juan is going to design a kite for mass production. After doing research, Juan creates several different designs and selects the one he wants to use. What are the next 2 steps Juan should do in the design process? So after research, he creates different designs, multiple designs, and chooses one. So after you do research, develop possible solutions, and choose or select the one solution, what do? You should build and test. Which one of these is build and test? Build, so this has build, this has build. Build and finish? No, build and test. Build, test. Those are steps 5 and step 6. Okay, which of the following orthographic drawings, orthographic projections, best represents this pair? So here, if we just look at the front, this is going to be the front. Draw it. That's one way I look at it, is this is the front. Which one? It's a bad drawing here, but let's go with it. Which one looks like the front? Front, no, yes. Okay, let's do some more investigation. The side would have this and this, so the side should be that, and then another little triangle like that. Yep. And then the top would be this and that together. So the top would look like something like that. Yep, B. So this is front, side, that's the top. Front, side, top. 29. A working drawing of a mechanical puller is shown below. What do the circled numbers on the drawing represent? So you have circled numbers, circle, numbers, circle, circle, circle numbers. 1, 2, 3. It's not the quantity. No, they're not talking about this. It's not the quantity of parts. It's not the size. This is not the size of the parts. It's the order of assemble. Assemble. The order in which you assemble parts. First you assemble this, and then this. A group of students is going to design and build a new set of shelves for a school. Which of the following describes the first steps of the design process the student should do? First steps, design process. First step, you find out why the shelves are needed. This is define the problem. Define the problem. Why do we need the shelves? And then you research the problem. And then the last question, how many views are usually necessary in order to describe an object using an orthographic projection? Well, orthographic projections, most of the time we need 3. Front, side, top. So most of the time we need 3 views. But sometimes you can do with only 2 views. If you have a can of soda, so if this is a can of soda, this from the top looks like a circle, like that. From the side, doesn't matter which side you look at, it's always going to look the same. That's a can of soda. The side will always look the same. This is 2 views, so 2 or 3 views. Okay, that's it. I hope this was helpful.